We are looking at activity 5.1.4. Alright, so we have the graph of a function. And so I'm just making the graph now. And so to the left of 0 we're 0, then we rise up to 1, 1, and then we fall down to 3, negative 3, we rise to 5, 3, we fall to 6, 0, and then we're 0 again. And this is the graph of G. And so what we want to look at is the function a of x, which is defined as the integral from 1 to x of g of t dt. So instead of calling this axis x, we're going to call it t. Alright. And then this would be our y or our g axis. You could think of it either way. So we're going to be asked to answer a bunch of questions about it, and I think it makes more sense if I go a little out of order. So we're going to start with part D. And so we want to find the exact values. So I want a of 0, which is equal to the integral from 1 to 0 of g of t dt. But notice that the bounds are flipped. So I'm going to have the negative, the integral from 0 to 1 of g of t dt. And now, from 0 to 1, I've got a triangle, alright, with a length of 1 and a height of 1. So it's 1/2 times 1 times 1. And don't forget your minus sign. So that would give us a negative 1/2. And then we want to find a of 1. Alright, but that would be the integral from 1 to 1 of g of t dt. And so we know that's defined to be 0. Then we have a of 2, which is the integral from 1 to 2 g of t dt. Alright, so if we look up here from 1 to 2, we've got this above and this below. But since it's falling at a constant rate, it's hitting at a half here, which means that the size here is the same as the size here, and they're opposite in sign. So overall, alright, I've got 0. Then a of 3 would be the integral from 1 to 3 of g of t dt. So that would equal, so we've got those things, and then all the way to 3. And now, it might be easier, instead of doing the trapezoid, to go ahead and get these two triangles. So I've got 1/2 the base, which we said was a half, because it's halfway here, times the height, which is 1, and it gets a positive sign because it's above the t-axis. And then we have 1/2 times a base of 1.5, which is 3/2, times a height of 3, and it gets a minus sign because it's falling below the t-axis. So that gives us 1/4 minus 9/4, which is equal to negative 8/4 or negative 2. Negative 8/4 or negative 2, which agrees with my work that I did earlier. So now we have a of 4, which is equal to the integral from 1 to 4 of g of t dt. And notice we have the same little part of the triangle above the t-axis, so we already know that area is a quarter. And then we have the area of this whole triangle, alright, and the base would be 1, 2.5, which is also 2.5 would be 2.5. 2 times 2 is 4 plus 1, so 5/2. And then the height is still 3. Oh, we forgot our minus sign. And we want to multiply by a half because it's 1/2 the base times the height. So then we have 1/4 minus 15 over 4, which is negative 14 over 4, or negative 7/2, which you can also write as negative 3.5. And I'm just giving alternate forms. So then we have a of 5. And so we are going to integrate from 1 to 5 g of t dt. But we already know the integral from 1 to 4 is negative 3.5 or negative 7/2. And then we can do the integral from 4 to 5, which is another triangle, which is 1/2 the base of 1. And we get a plus sign because it's above, so 1/2 the base times the height, which is 3. Alright, so that would be negative 7/2 plus 3/2. So if I do 3 minus 7, I get negative 4 over 2, which you can also write as negative 2. And then a of 6 is equal to the integral from 1 to 6 g of t dt, which is equal to, negative 2, like we just found, plus this area, so 1/2 a base of 1 again, and a height of 3 again. So that would be 3/2, and so I'm going to write negative 4/2 plus 3/2, which is equal to negative 1/2. And so those are the heights. So I can go ahead and start sketching A. One, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And we have that a of 0 is negative 1/2. So if this is negative 1, then a of 0 is negative 1/2. So it falls right here. A of 1 is 0. A of 2 is 0. A of 3 is negative 2. So we're going to come down to negative 2. A of 4 is negative 3.5. So we got to come down 2 more. Well, 1.5. So we end up right here. A of 5 is negative 2. A of 6 is negative 1/2. Which falls right on my 6. Okay? So we know those points. But we still need to think about where is it increasing and decreasing, and where is it concave up and concave down. So, here is something to think about. We have 1 and 2 at the same height, so something's happening between them, and actually it's happening right here where it crosses at 1.5. So we have to figure out what's happening before it and what's happening after it. Alright, and so if we want to compute it, a of 1.5 would not be a terrible thing to actually try and compute. So let's go ahead and do that. I'm going to say a of 3/2, which is the same way as saying 1/2. 1.5. So you get the area of this triangle. Oh, no. You integrate. Sorry about that. From 1 to 3/2, which is the area of this tiny triangle. So it's 1/2 times the base, which is 1/2. Oh, I forgot to write g of t dt. 1/2. The base is 1/2. And the height is 1, so it's 1/4. Okay, so if this is 1, then 1/4 would be, that would be like 1/2. So 1/4 would be like right here. And I think this will help us see why we have increasing and decreasing where we do. So we know that at a of 1 is where we're kind of saying, hey, that's going to be a 0. So if we're looking to the right of 1, over here, then we start to notice that this follows what we had been seeing before. So we're going to be increasing when we're above the t-axis. So that'll be increasing on the interval from 1 to 1.5 and on the interval from 4 to 6. And notice I have a comma, not a union. And so again, it's because it's above the t-axis and to the right of 1. And so then we're decreasing where we're below the t-axis on the right of 1. So that would be 1.5 to 4. And that's it. But notice what's happening on the left of 1. Alright? So, what is happening? Well, it's increasing, right? Because we started here, we went up here, we went up here. So that's still acting the way we expect it to. So that means over here on increasing, I also have the interval from 0 to 1. So really, what we should have written is 0 to 1.5 is where we're increasing. And 4 to 6. And then we're decreasing from 1.5 to 4. So actually, whether you're to the right or left didn't have anything to do with it. So this is simply because it's below the t-axis. Okay, so now let's look at concavity. So we have concave up and concave down. So if you remember, we're concave up when the derivative is increasing. So that would be from 0 to 1. But then from 1 to 3, we're concave down because the derivative is decreasing. And then from 3 to 5, the derivative is increasing, so we're concave up again. And then from 5 to 6, we're concave down because the derivative is decreasing again. So this is because g is increasing, and this is because g is decreasing. So we want to, from 0 to 1, we want to be concave up and increasing. So concave up and increasing, and then from 1 to 1.5, we should be increasing and we should be concave down. So I'm going to try and emphasize that. See how it's curving down. And then from 1.5 to 2, we should be concave down and decreasing. And then from 2 to 3, we should be concave up. And on 2 to 3, we are decreasing. So concave up and decreasing. We want to kind of have the bowl, okay? And then from 3 to 4, wait, did I do that right? 2 to 3, oh, we're concave down. Okay, so we have to curve the other way, don't we? So it should be curving like this. I apologize. So we're concave down, but then we're concave up on 3 to 5. So now we're going to get the bowl, but we're decreasing from 3 to 4. And then we're increasing from 4 to 5. And then from 5 to 6, we should be concave down, and we should be increasing. And then from 6 to 7, we don't change, right? So we're just going to shoot off at that height. And actually, less than it, we're also going to shoot off, because remember, it's just 0 there. So that's the shape. And this is our A of x. So does A have a relative minimum or a relative maximum? So the relative minimum would happen where you switch from, so if you want a min, you have to be decreasing and then increasing. So if we look, we're decreasing until 4 and then increasing, so relative min at x equals 4. And then for a relative max, that happens when you're increasing and then decreasing. So we're increasing from 0 to 1.5 and then decreasing, so at x equals 1.5, we should have a relative max. And notice that is a hot point, and we do have a min at 4. So that's our A. Now, So we actually have done, because that was C, that was D, this was A, increasing and decreasing, and then B was the concavity, and E is the graph. F, what happens if you have B of x starting defined to be the integral from 0 to x of g of t dt? Well, then what that tells me is 0 of 0, at 0, your height is 0, because the integral from 0 to 0 is 0. Alright? But it should have the same shape otherwise, because all the other areas have stayed the same on your derivative. So we go, and then we go up by half, and then we go up by a fourth, and then we come down by a fourth, and then we come down by 1, 2. So 1, 2. So it actually is just falling. Okay, and then we come down by 1.5 more, it looks like. And then we come up by 1.5. We come up by 1.5. So it's falling just above. Yep, that is cool. So this, and I'm going to dash it so it's easier to tell them apart, is the graph of B of x. So what's happening is this lower bound on B and A is really giving us the constant of integration. And so these are parallel curves.